This particular panel will focus on demand flexibility. As you all know, the answer to some of the challenges that we are facing right now is not always on the supply side, but it's actually on the demand side as well. So on the stage, we have our moderator for this panel, Dave Maggio, who is the Principal of Market Design at ERCOT. We have Michael Lee, who is the CEO of Octopus Energy North America. We have Dr. Lachey, who is a Professor of Electrical and Computer Engineering at Texas A&M. We have Maria Belenky, the Lead Market Design Specialist, PJM, and Jesse Aragon de Galvez, who is a Staff Technical Program Manager at Tesla. They're already on the stage. Dave, it's all yours.
Thank you very much. So obviously this panel's on demand flexibility, and we have a long history of demand response in the ERCOT market. So from probably a couple of decades at this point, that started with a lot of participation in our response reserve service and our emergency response service. Again, largely large customers participating in those ancillary services for 20 years, talking about gigawatts of participation. In more recent years, we've tried to expand that, again, primarily focused on ancillary services, so trying to open up the door to our non-spinning service, to our ERCOT contingency reserve service. Again, those have been largely focused on large consumers, for example, industrial consumers participating in those services. But in the last couple of years, we've talked about expanding that to new customer bases, and specifically with the support of the Public Utility Commission of Texas, we have a virtual power plant pilot program going on in ERCOT, or because we have to have a different term for everything, we have aggregate distributed energy resources, or ADERs, as part of that pilot. And we'll get into a little bit of that, but trying to open up the door for demand response participation from not only the large customers, but bringing into the small commercial, bringing it into residential homes for direct participation in the wholesale market. In addition to that, there's all the other things going on that ERCOT's not administering. So there's a variety of programs that our electric providers are administering that we kind of find out and really only know about through some annual surveys that we do, but there's, again, a variety of programs out there that are being provided directly to the customers. We also simply have all that passive demand response, where we see, again, typically large loads who are responding to wholesale prices, not necessarily coordinated through ERCOT, but they're responding to what they're seeing on the grid, particularly when we start to see that scarcity and prices getting high. Now, all of that provides a lot of reliability, value, and benefit to the grid. And so we think this is a very important topic today, and I'm very happy to have the panelists here. Want to talk a little bit about what's going on now. And again, this is, while we've had participation for a long time, really a growth area. So where's the greatest levels of potential? So with that, Michael, I'll start with you. Obviously, Octopus is in the competitive retail electric provider space. Can you talk about, what you all are doing, some of maybe the unique ideas you have, or the things that you are all doing that's a little bit different?
Sure. Happy to talk about that. Maybe I'll kind of start my comments about more of a reflection. How incredible is it that an ISO is having an innovation summit? Like, historically, I would not put those things together. But as you think about the grid is changing so rapidly. And to hear that ERCOT is open to thinking about what does the future look like, and open to the conversation of new ways of running a market, new ways of doing stuff, hopefully with the idea of bringing down costs, improving reliability, both at the same time, is quite fascinating. So who knows, maybe fast forward a few years and the I in ISO stands for innovation. And going forward, but maybe some more context on exactly what I just said. ERCOT released a study a couple weeks ago. We're potentially going to double our loads in the next 6 years. I would kind of look at the next 10 years, and I wouldn't be surprised if we had an unlimited supply of power that probably we would triple or even quadruple our loads in the next 10 years. And it's not just ERCOT. Like, we see it throughout the rest of the US. We've all seen the headlines. How are we going to build enough generation to keep the lights on? We see it, quite frankly, as a global company. We see it in every single country. It's not an ERCOT phenomenon. It's not a US phenomenon. It is just the moment in time in which we're moving into an electron-based society instead of so deeply in a molecule-based society. And that's just a natural kind of progression as we just think about these nearly free electrons coming from wind and solar. Markets have a great time using free, right? So free is good. It may not be good for developers at first, but we as consumers of free power, load-serving entities, need to rethink our role on the grid to be a participant in that. And so we at Octopus, we hyper-focus on that customer experience. If we're truly putting the customer first at every single thing we do, we'll both have a better customer experience and a lower cost product. And so the way that that's reflected here in the US, and particularly here in Texas, we have our signature product is what we call a smart rate. So instead of a standard rate where every hour of the day is the same price, and the next iteration that everyone often talks about is time of use rates, which are better, it's a step in the right direction. We leapfrog around that and we do what's called a smart rate, where it's still what a customer wants, which is a flat rate for every hour of the day, but they get a discount that reflects the controllability and flexibility that we have into that asset. So the more devices you interconnect into our platform, the more we're on the hook for going to create that flexibility. Currently here in ERCOT, we see some really bright signals to do a lot of that flexibility. It's a pretty binary signal. It's mostly around energy. We're moving through things, like you said, into ancillary markets. And I think the more signals that we see, the more that we can co-optimize on our side between customer preferences and all of these signals to create a more efficient grid with the already built environment. And so as a retailer, I think our opportunity and what I call retail 2.0, historically retail 1.0 has been a lot of low introductory rates with high fees. Retail 2.0 allows us to be a central actor in creating the maximum of flexibility, which drives down costs for us, which in turn we share with customers to create some of the lowest cost products in the market. And so I think that our incentives, our customers' incentives, and the grid incentives can now be highly aligned in this new world that we're moving into.
Thank you very much. And I think there's a lot of things we'll want to come back to in what you said. But next I'd like to jump, actually, if you don't mind, to Jesse. Obviously, Tesla's gotten very engaged in this space. Of course, what immediately comes to mind is the engagement in the pilot program that I mentioned. But can you talk a little bit about what you all are focused on right now?
Yeah. So I think I can sum it up in a few bullets, and I'll elaborate on some of those. But the few things that we're really focused on right now are, number one, in improving the value that we can get from these resources that are flexible on the grid, and finding ways to share that with the customers to improve or greater the value proposition for these products that enable the flexibility on the grid that we're all really seeking here. The second one that I would say, and taking a page out of Michael's book, really focusing on enhancing the customer experience. The Tesla virtual power plant here in Texas is administered purely through the Tesla mobile app, and we found that to be a great vehicle to deliver really grand customer experiences that give them visibility into the things that they care about, allow them to configure the things that they want to have control over. And then the last one, I would say, thinking a bit outside of just Tesla, continuing to invest in our APIs, our tools and systems that can be boxed up and packaged up and provided to partners and other service providers to enable our partners and other retailers and other market participants to enable a virtual power plant customer-facing program that delivers these sort of incentives and a great customer experience all in one. So yeah, of course, very focused on our offering, but as well focused on the technology to expand this sort of thing and make it an easier on-ramp for other service providers out there that are looking to do it.
Thank you. And maybe we'll switch a little bit and go to you, Lei. Obviously, you've been doing some research in this area, including a couple of engagements with ERCOT right now. Can you talk a little bit about the work you and your students are taking on?
Sure, I'd be happy to. First of all, I want to congratulate ERCOT, Venkata, and all the entire team here for putting together this absolutely wonderful event. As we do at the university, what do? We do innovation every day. And when I was talking to my students, the way we do research, most of the time, we're thinking about doing research out of curiosity. But this time we still do that, but in addition, we do research out of necessity. because we got to keep the lights on here. And when I'm talking to my students, say, your research and the actual impact in the real system is just about an hour and 30 minutes away. And I mean, that really gets students excited, right? So I wanted to congratulate the entire ERCOT team for putting this together. Exciting the human talents, I think, is absolutely the number one thing that everybody here would hopefully agree with. Regarding the specific research that we had the honor of doing recently with ERCOT as well as the PUCT, it was really exactly about this question of how are we going to tackle the peak demand in the upcoming summers. So let me just kind of give you some context. I was called upon on the very night of Winter Storm Uri 3 years ago at the National Public Radio, All Things Considered. And you can check on the record. I was making the remark at the time, I said, while we're solving the problem right now of the supply issue, can we be a little bit smarter about things on the demand side? And now, just fast forward 3 years, guess what the peak demand was in 2021 versus the peak demand was in 2023? You thought the winter storm Uri was a big deal? You thought that's a big deal, right?
Yeah.
Summer of 2023 peak demand make winter storm Uri look really, really low in terms of peak demand. It was 7 to 8 gigawatts of increase compared to the winter storm Uri peak demand. So that's the kind of circumstances we have right now. So the question is, what in the world can we do something to really kind of push down that peak demand in the summer, who knows when, one of the August days in 2024, right? And I think, of course, the simple answer is that you have to have an all-hands-on-deck approach when it comes to harnessing the demand flexibility. More specifically, we looked into things that are perhaps has been less tapped into before and perhaps having a bit more potential in the near future. And that boils down to a couple of specific areas. One of the area is each and every one of your houses. I don't know about if you know this or not. In a peak summer day in Texas, the residential sector consumes just about half, maybe a little less than half of the electricity. And out of the entire residential consumption of electricity, more than half is just devoted to one particular device. And you know what device that is, right? That's the keeping our house cool, the air conditioning. So as we looked into the very latest ERCOT demand response report of 2023, we look at all the numbers of different categories. One thing that we see was very, very thin was this so-called weather-sensitive ERS, emergency responsive services. In layman's language, in some sense, it's like harnessing the residential sector demand flexibilities, right? So what do we do to harness that? Can we go from 40, 50 megawatt to like 5 gigawatt? I think that is very well within the reach as long as we put our acts together. So what are the acts we got to put together? I think you got to put your acts on two things, technology and the market. On the technology front, you want your house to be smart, otherwise you couldn't do this, right? So that means we need to roll out a lot more smart thermostats. Just to give you some base number. Here in the state of Texas, we have a little less than about 15 to 20% of the households, single-family households, that are equipped with the smart thermostat as of today. So there's still a lot of room to grow from 15% to, let's say, 85%, right? So that's on the technology front. But technology alone will not get us there. We will also need all kinds of innovation on the market design and policy design and programs like Michael's to really tap into the technological innovations and then incentivize the customers to do the right kind of behavior during the peak hours. So I think sort of that's one of the area that is perhaps historically has been less tapped into, but we see a lot more potential out there. So I'll stop there. I'd be happy to take more comments later on.
Got it. Thank you. Yes, and again, you all are kicking off some good questions here for later in the panel.
Absolutely.
Maria, we'll jump to you next. Obviously, I imagine most of the group here is fairly Texas and ERCOT centric. Obviously, coming from PJM, would you talk a little bit about, similar to what I was talking about with ERCOT, what's sort of the evolution been of demand response in PJM? Sort of, where are you now, and where are you trying to go in the near future?
Yeah, absolutely. So PJM has a long history of demand response participation in the wholesale market, anywhere from the residential to the large industrial customer classes and everything in between. The programs have gone through several rounds of changes, evolutions over the prior years, from different summer versus annual products to annual product, but really the foundational opportunity has remained the same. In terms of today, we permit demand response to participate both on the supply side and the demand side. I think the latter is fairly unique among ISOs, RTOs. A bit more detail about this. The supply side is probably what everyone here already understands and is familiar with. Demand response can participate as a capacity performance resource. They can bid into the base residual auction, to the incremental auction, and have a capacity commitment. These are emergency or pre-emergency resources. We call them at times of stress on the grid. We also have economic demand response, where the resource participates as a generator, make bids into the market, and are dispatched economically. Now, the aggregator does not need to choose one or the other. You can be both a capacity and an economic resource. I may be getting these numbers wrong. Probably half of our economic resources also have a capacity commitment. So it all depends on the customer class and what their willingness is and capabilities are, but you can be both an economic capacity resource and, of course, provide reserves and regulation, other market services. On the demand side, we have a program called Price Responsive Demand. Rather than modeling you as a generator, we model these resources truly as load and changes in load. They also bid into the capacity auctions, receive capacity commitments. In the day-to-day operations, they provide price megawatt pairs to PJM, and we are treating this as load that we expect to be off the system if prices reach above or beyond the price designated by the aggregator. We do not dispatch these resources. They are expected to be off the system automatically. And now there are certain requirements for customers to participate in price responsive demands, PRD. You have to be on a time varying rate of some sort. That doesn't necessarily have to be a dynamic pricing that varies hourly or more granularly. It can be things like summer peak pricing and potentially TOU, although I'm not entirely certain that we have those in the system. But you have to be on a time varying rate. You also have to have some sort of technology that automates load reduction. So the curtailment service provider or aggregator has to have supervisory control or the ability to remove load from the system, quote unquote, at the push of a button. These resources receive capacity payment. They do not receive an energy payment. That's simply because we are expecting them to have cost savings from being on a time varying retail rate. So these are the programs that are in place today. There are two areas of focus for us moving forward. One is the DER aggregation model that is stemming from for quarter 22-22. We are in the process of designing this model and permitting resources not only reduce load, that's traditional demand response, but also inject into the system where DR is not permitted to do that today. There's a lot of opportunity there, of course, as the amount of solar, behind-the-meter battery proliferates in PJM. We are designing that program. We hope to stand it up by 2026. We have a filing currently at FERC, so it's not fully approved and times may shift, but really looking forward to having that model in place. The second area of focus is the integration of large loads. We are expecting massive load growth from data centers in the coming years. I think many of you are familiar with Data Center Alley in Northern Virginia that's in the RTO's footprint. And we're trying to determine what flexibility exists within these resources, and to what extent we can harness that flexibility in PJM's markets. Our current demand response programs enough, or do we need to redesign or redevelop market access opportunities to match the capabilities and needs of these resources? So a lot of focus on the integration of large loads going forward.
Thank you very much. Yeah, I guess maybe I'm going to switch the order of questions just to play off of what you were talking about. I was wondering if you all can kind of talk about, from your point of view, what's the economics of demand response, trying to get customers engaged, whether it's the residential customers or the large flexible loads. Can you all maybe get into a little bit more detail in terms of, are the existing structures enough? Is there enough ancillary products in the wholesale market, or do we really need to think about new products or participation models?
Yeah, I'm happy to jump in there. First, I want to set some context around the retail electricity offer that Tesla administers here in Texas today. It was, kind of the flagship offer that we launched, where our retail customers that had a Powerwall storage device at their home were eligible to join Tesla's retail electricity program. Today, more than that are eligible. We also have recently expanded to allow any retail choice customer in Texas to join our plan and program, and additionally have benefits that are, focused on customers that have flexible products. But the one that I wanted to highlight was the residential storage battery, our Powerwall, and the offer that we have designed around the flexibility of that Powerwall has a time of use import component. So customers, of course, have fixed time of use windows throughout their month-to-month retail plan. And on the sell side, or on the buyback side, is what we traditionally hear it called in retail plans, instead of offering a fixed or flat buyback rate, we actually compensate customers at 90% of what the real-time spot price is in that moment when they export energy back to the grid. Now, in that customer app that I mentioned, where we administer that retail electricity program, customers have many bells and whistles and knobs to configure their preferences. One of the big ones that customers really love to have agency over is their backup reserve slider, which is what we would consider the minimum charge level that Tesla would ever operate that battery down to, that the customer feels comfortable with. So we see customers setting their backup reserve level, anywhere between 20 and 70, 80%, some folks all the way up at 100, because they value energy security above all. They might rather have a higher month-to-month electricity bill if that means they will have storage available in the event that they do not have power coming from the grid to their home. Now, the largest revenue stream for customers, right, on that retail electricity plan is the energy arbitrage. They're buying energy at prices on the order of 10 cents per kilowatt hour, and in these big events when the market is quite strained, we see prices go up, dang near the cap. And the market is getting even more volatile. I believe it was just last week on the 8th, we saw prices go up quite a bit and saw quite a bit of customer engagement in that app. And customers were compensated on the order of $2 to $3 per kilowatt hour that they exported out of their battery in that moment to the grid. Now that was kind of the starter, or I guess the 1.0 version of the retail plan. But as Dave mentioned, the ADER pilot program has been something that has been progressing quite rapidly here in Texas, and we are one participant of the ADER pilot program and have managed to qualify and telemetry test and basically validate that these devices could respond to an ERCOT dispatch command. And once those devices were qualified, they are now able to be compensated for providing those ancillary services that we were talking about before. So the non-spinning reserve service, and now the emergency contingency reserve service, the ECRS service, which is new. And our optimization and algorithms teams are consistently iterating and improving our models and our algorithms that drive or steer these batteries, that tell them when the best time to hold energy back or export energy to the grid might be. So as we've continued development, and iteration, we are still sharpening our pencils and understanding kind of what the optimal mix of locking capacity to provide ancillary service versus freeing up some of that capacity to do energy arbitrage is. Right now, there's a good mix going into what we're doing with the customer batteries. But as we mentioned before, these inverter-based resources like the Powerwall battery are very, very flexible. They can respond very quickly. They have ramp rates that are through the roof. And we think this means that these batteries are more flexible than just able to provide the reserve services. I was telling an anecdote to the panel just a moment ago, but my home is in Pflugerville, Texas, just on the edge, but I am in deregulated retail choice territory. And we use mine as kind of a guinea pig test site and do crazy things with my battery. And they're always asking me if they're okay if I take full control of it. But yeah, we were like setting droop curves on my battery to show that, in the event of a frequency disruption on the grid, that our Powerwall device could respond and match and help get the frequency back to where it would be. Thinking forward about maybe one day enabling a frequency response service in the residential ADER pilot program. And there are, of course, other services that we think these batteries can provide, but we have a great start with the reserve services today, and they do meaningfully increase the value that can be extracted from the flexibility of these devices. There's always been kind of the value of load shifting for the retailer, taking that stored energy and using it to power the home during peak pricing periods. The retailer can reduce their cost of service and share that benefit through to the customer. As Michael was mentioning, being able to offer some of the best retail rates that are out there by leveraging that flexibility of the battery. So that's really my view on kind of the expansion of the revenue and value that can be accessed. And I think there's a lot more room to grow there in terms of the services that these systems can provide.
Yeah. Absolutely. From the perspective of an RTO, so looking back at total megawatts that we have participating in our various demand response programs, it's been fairly stagnant over the past 10 years or so. There are, of course, ups and downs. After implementation capacity performance 2020, we saw a bit decline, a bit increase. But we're probably averaging around 8,000 megawatts, give and take. That, to me, says that there's still untapped potential. And of course, it's just thinking of what else can we offer, what kind of value can be gained to incentivize additional load flexibility to enter PJM's markets. One option that we are, again, looking forward to is the DER aggregation participation model, the ability to get paid not just for load reduction, but also for injections into the grid. We hope will provide the additional economic incentive in order to participate. The other part of this, I think, the answer to the question of whether or not existing models are enough or not depend on the customer type. With respect to things like large loads, data centers, there is a question in my mind in terms of whether existing demand response participation options are appropriate or adequate. Then you start thinking about whether there are additional incentives that can be put in place or gained by the customer in order to incentivize them to offer flexibility into the market. And these incentives may not necessarily be economic. Maybe the additional dollars that can be gained from additional services is not enough. Maybe it's something like being able to follow greenhouse gas emission signals and being able to reduce load when the emissions are high on the grid and climate impact, contributions to reliability and things like that. So really trying to think through non-economic value adds that can be offered that could be of value to load types that have not traditionally participated in demand response.
I want to separate this issue into two categories. What do we do with the large flexible loads, and what do we do with the small residential loads? I think Maria already touched upon a lot of very good points about how to deal with these large loads. Just to kind of contrast what's going on in PJM versus what's going on in Texas, we also see a lot of computing loads growing, but in another form, the other form called cryptocurrency mining. And then you wonder, well, they're all computers, what's the difference, right? So the biggest difference is that these guys are much more flexible compared to data centers because you need to keep your Zoom call on no matter what. But these guys, you can just shut them off. And we kind of did some empirical studies thanks to some collaboration with ERCOT, looking at how price responsive these emerging computing loads are in the peak summer of 2022. And we noticed that there is a significant flexibility that you never see in any other category of load. So coming back to your point, for these large loads, the key is really to just lower the barrier for them to participate in all kinds of energy or ancillary service market possibility. I mean, they are already doing that. We can probably do a little bit more aggressively, like ECRS, ERS, and so on, right? So that's for the large ones. For the smaller customers, I don't think that ERCOT or PUCT is in a position of instrumenting a particular program for a particular customer. That's not the business of RTOs or the policymaker. But it is in the business of RTOs and PUCs to perhaps send some incentive programs or set the right signals so that the proper technology and the proper business innovation will come together. For example, whatever that we can do to incentivize the more rollout of smart thermostats, whatever that is. And then on top of that, whatever we can do to let more companies like Michael's and others to just mushroom and come up with innovative ideas of free beer or free this, free that, to just let the market figure it out. But we need to just incentivize more Michaels, right? More startups, more entrepreneurs to figure out the business innovations. But we are not in the business of picking losers or winners, but we are in the business of sending the right signal so that there is enough of competition out there. Right? And Texas is just fertile ground for that, right? So.
Michael?
To clarify that comment, last summer, Octopus took our customers and, frankly, anybody who showed up with a picture of their thermostat at 80 degrees. We took them all out to the bar, and we just gave them free beers during.
So the real story.
During a time when the grid was $5,000, because we want to find creative ways. Customers should not feel uncomfortable just because they're participating in flexibility. They can get out, and we can reimagine what it looks like for them to participate in flexibility. But to your question about are there enough revenues in the system for that, maybe to answer a different way, there are a lot of revenues in the system right now. Like, look at consumer bills, right? We are dealing with some of the highest hedge costs, highest bilateral prices. You can just look on ICE. Heat rates are astronomical. It has never been more profitable to be a large generator than any other time versus today. This is incredible times for the large generators, and it is all coming at the consumer's expense. And so we need to rethink about how do we drive innovative costs, and a piece of that is the spread between what it costs to buy a 16-hour on-peak block of power over the summer versus what real-time prices look like for the vast majority of those hours, that spread has never been greater. So how do we rethink what it looks like to use cost throughout the daytime, and what does it look like for a load profile? And so, as a load-serving entity that has to bear these costs and, talk to customers about why their costs are going up, and it's not because natural gas prices are going up, it's because generators are just making a lot more money in this environment. And so thinking about ways to shift that usage to cheaper times of the day, really exciting because we can lower the cost of serve quite drastically. Then when we think about, second and third steps to keep trending down that path, Jesse talked about ADR. Really exciting ways to find some of those revenues that these large generators are soaking up. How do we enable individual Texans to participate in some of those revenue streams, right? How do we reward them for doing the things that these large generators also are doing? But that requires a new type of system, right? What we're talking about is millions of customers with millions of devices on a highly decentralized grid, all interacting as if they were a large generator. And so the skill sets that a system operator would need in order to kind of go do that new future, well, it's a very technology-based skill set. And quite frankly, it's also a different mindset, right? Like, we are moving from a world where it used to be quite discrete, right? You had very specific assets, they did very specific things, and you got high confidence of exactly what it was doing. I guess not always. We talked about earlier, they lost visibility and telemetry to some of these assets. But there's a lot more discrete interaction. And what we're moving to is a probabilistic grid, right? We're thinking about, no one individual asset is actually a central point of failure anymore, but how those assets are operating is much more probabilistic, and it creates a portfolio approach to managing a grid. And so that transformation at the ISO level is really exciting as we kind of think about the evolution of the grid. And then quite further, when you think about revenues, like in some framing, in the old Silicon Valley speak, volatility in this world, short-term volatility especially on the wholesale market side, it's a feature, not a bug. It rewards us for shifting usage to the time when the market is signaling that it's actually oversaturated with electrons and away from the times where we're a bit more constrained. And so that volatility, that short-term volatility is really helpful, but that's only expressed kind of in one element of the energy transmission and distribution equation. And so when we think about unlocking the already built environment, we have transmission, we have distribution, there are lots of money that we're putting into the billions of dollars we're putting into these systems. How do we digitize these things so that way we can more efficiently use the assets that we already have and the assets that we're building, so that way we're not building to the max, capacity that we have for 15 minutes on like 1 every 10 years, but in fact we're able to flex that usage to accommodate not just the energy markets, but the transmission and distribution markets, because wow, that unlocks the already built environment, which is way faster than building CapEx.
Thank you. And I do want to go to questions from the audience, but I want to have one more before we do that. Michael, you kicked it off by starting and talking about customer engagement, the customer experience. Jesse, I think you all talked about customer experience to some degree. Whether it's the app, whether it's the changing mindset, and maybe Mike will start on here. How's that changing and how you're engaging with customers? And actually maybe with that, are there areas where you're still seeing a lot of confusion from customers as you try to make them part of the overall solution to solving problems on the grid?
Totally. Like, look, we sell an invisible product. You know how hard it is to sell an invisible product? Your customer can't hold it, they can't smell it, they can't taste it. Like, it is by definition a trust-based product, right? So like, why don't we have a Buc-ee's in energy, electricity? Why don't we have an HEB in electricity? Why don't we have an Amazon or Apple in electricity, right? Like, how do we have customers that when they see, something fun like this, they get a little smile on their face and they're like, yeah, okay, this actually doesn't have to be extractive, that you can create a true consumer relationship, a true consumer product. And so when we think about, grid flexibility, it is the next derivative of a trust-based product, right? Like, we're already selling an invisible one. Now it's, by the way, we want to work with you to help, do this thing that the grid cares about, but we're not going to do it for that reason. We're going to do it for a consumer reason. And that consumer reason is lowering your costs. Because, by the way, soaking up all these free and abundant renewable energy electrons that kind of show up every single day in the middle of the day, wow, that can totally drive down your cost as a customer, and you won't have to even touch your thermostat at 5 o'clock when you get home from work. And so that trust-based business model, that's retail 2.0 in a nutshell. And the faster we can accelerate into a true consumer experience, the more flexibility we'll get on this grid. And as we talked about earlier, the hardest times are the extreme weather times. And it's not because factories are producing 3 times as much stuff. It's because households have temperature-sensitive loads. So that challenge is also the solution, but the solution can't be approached with the old tools. They have to be approached with a new mindset and experience.
I want to just raise a challenge. I don't necessarily claim that I have the answer, but I think there's a challenge we all face to your question. The challenge is, how in the world do we understand consumer behavior of electricity? I challenge you because I don't have a good answer, and I think perhaps nobody has a good answer. And that's something we all need to do together. We used to not care a lot, which is okay. We just do load forecast. aggregate the city of Austin, this, okay, a little bit margin, that's fine, no problem. But now we are doing this, fine granular household by household resolution, understanding, Jesse has a smart, super smart house, and then this behavior is totally different, and so on. That is just something we have not fully get understanding of. And in order for us to claim one day the demand flexibility is going to reduce the peak power by 10 gigawatt, no problem, trust us, that reliability standard that we are looking at, that is the biggest gap. Because no one can guarantee you that, oh, I'm just going to call Jesse and he will respond. So, of course, the simple answer is you got to do a lot more research into that. But the hardest challenge there is really, I think, we're sort of beginning to develop a very categorical type of behaviors, like weather sensitive behavior. Like this EV charging, that is up and coming. We're having a new project now with ERCOT about just figuring out the charging profile for Texas, right? All this categorical behavior, we are just begun to scratch the surface. And I would love this entire ecosystem to really focus and study on this problem, because it's going to help all of us.
So I'd like to comment maybe a bit of background about me. So prior to joining PJM, I worked for Home Connect aggregator based in California, rep in Texas. They're now Renew Home, merged with Nest Renew. And we work primarily with small residential, small commercial customers. So mass market product, customer engagement, customer education, that was probably 60% of the battle in terms of getting the load flexibility and load reduction. These customers do not think about energy day to day. So anything basic from educating on how the grid works, what different types of stressors are. We had people on the phone with customers helping them install smart thermostats. They could participate, really walk through every single component of the process, and that's before the event. And then during and after the events, really helping customers understand why we need them to do what they're doing. So I was at Home Connect during August 2020 in California, the grid events, Labor Day, September 2022 as well. And communication, understanding of why we are asking customers to potentially be uncomfortable for a few hours was incredibly important and key to getting the maximum load reduction. When they understood that the emergency grid conditions, this is what you can personally do to help. This is why your participation is important. And this is why we're asking you to potentially be uncomfortable for a couple of hours is massively, massively important.
Yeah, all great points. I mean, I think there is this natural tension, right? I think we see these smart devices and we see flexibility, right? And the ability to smooth kind of the nastiness that comes out of these duck curves sometimes. And what customers buy these devices for are not the same thing, right? They're not buying these devices to enable grid flexibility, right? You buy a smart thermostat so you can not think about turning your AC on and off, right? And you can set a schedule. Or you might buy a Powerwall device because you want home backup. Or you might buy an electric vehicle because you never want to go to the gas pump again and it's cheaper for you, right? And this tension is really the thing that we're trying to overcome through these customer experiences, right? And it's kind of the challenge that we're grappling with right now in our Tesla app is how do we strike that right balance of giving the customer the needs or the things that they bought that device for, but also allowing them to tune the knobs and optimize it in a way where they can realize the maximum economic benefit of those devices as well. Creating these, to take a word out of Michael's mouth again, this alignment of incentives, finding ways to align the incentives of the customer and the grid. And that is what I think can be solved through customer experience and innovative retail electricity rate designs. And that's really what we're at the forefront trying to do here with all of our partners in this room is innovating these retail electricity offers, innovating the customer communications, the experiences, the feedback loop, so we can understand what these customers do value and how much intervention is too much. So that way, when these devices are all synchronously communicating to one another in an integrated fashion, and ERCOT knows exactly what it can rely on from these devices, it should know what it can rely on by subtracting out the amounts that the customer wants for their own purposes, right? So that's what we're trying to do in the Tesla mobile app customer experience. And yeah, it's definitely a constant iteration. I will say we are learning. You know, these are new services that residential devices are providing. And it's not something that customers are super familiar with, to maybe have a portion of their backup battery committed to providing some ancillary service in the market. But finding ways to show customers what the value associated with that is, the level of control that they have over it, and the ability to opt in and opt out. You know, those are some of the key kind of levers that we found have, mended some of the tension from, that customer experience battle that I was just talking about.
And I know one of the biggest questions for ERCOT and the control room in particular is that situational awareness of, I know these resources are out there, how much can I really depend on? It's just a very different mindset, Michael, as you were talking about. With that, we have a little over 5 minutes left. I'd like to go to the audience questions. And Venkat, if you want to read the first one.
Sure, Dave. There are quite a few questions that have come through the Slido here, but I'm going to pick one which I thought was interesting. It's about interoperability. Your devices are made by X company, and you want to participate in services that are offered by Y company. What are the obstacles and what are the opportunities with that?
It's a great question. So to clarify, there's a proliferation of different types of devices. EVs, batteries, hot water heaters, thermostats. Like when we think about load growth, a lot of that load growth is controllable. And a lot of those controls technologies have APIs or ways that third parties can control those. And so I think the genesis of the question is, how do we think about interoperability and third-party controllability? Is that something we should be concerned of as we think about, as we grow these loads or perhaps have new interconnection standards on the grid? And I think that at the end of the day, those interoperability standards ultimately create competition. And when you have competition to who gets to control the device, then a result of that is the customer wins, right? Because what it comes down to is whoever gets to control that device in the most customer-centric way, and that depends on what that customer cares about, then that's where that customer will choose. And so I'm personally a really big fan of interoperability. I think it helps create a wide variety of different types of products on the market that will enable further competition.
Anyone else on the panel?
I would like to echo that by just saying that think about our industry. Our industry is actually a great example of interoperable devices. I bought an Apple laptop, and this is made by Apple. I plug into the wall, and then the socket is made of, Eaton or someone, and then that is then got connected with a transformer that is made of ABB, and then that is then got. So interoperability is there. We just haven't got yet comfortable with the same notion on the demand side, especially when it comes to flexibility. So it's, I think, just like what was earlier alluded to, having some of these standards set up in place, and we don't have a good answer to that now. So there's a bit of urgency there. We really have to think about what exactly should be the proper interface design for demand flexibility, massive demand flexibility. We don't have a good answer yet, right? So.
Venkat, another question in our last couple of minutes here?
Sure. There was a comment made that residential load makes up almost half of peak load. Should there be larger focus on energy efficiency, and what is the potential?
Since that was my comment, I'll make that answer. So energy efficiency and load flexibility, especially around temperature-sensitive loads. Look, it does us no good as a retail energy provider to inject heating or cooling into a building and to have it just immediately leak out, right? So we're now in a world where our incentives are aligned to rethinking the world of energy efficiency. And it's like the old world of thinking about it was using less electricity, using less kilowatt hours. That's the wrong framing. That is a world of coal and gas where every kilowatt hour had a cost to it. We're moving to a world where a lot of kilowatt hours will be effectively free. So using those kilowatt hours is not necessarily a bad thing. What we really want to do is soak them all up and make sure that when we do something with them, they actually have the longevity of actually having an impact. And so we have some houses that have incredible energy efficiency, or what we call thermal envelopes in their houses. And we can go through a 20-degree day in Houston or a 105-degree day in Houston and do an 8-hour flexibility event, and they only change by about 4 degrees. And so when we think about what flexibility looks like, it's not just using power when it is most abundant, but it's also when you inject that power into a house via a thermostat, that it actually holds all that energy that you've already used within that system. And so we're really excited about rethinking what energy efficiency looks like, because it's such a vital peanut butter and jelly approach to actually doing temperature-specific load flexibility the right way.
Anyone else want to share anything on that?
I just want to say very quickly, we did a major study for ERCOT about energy efficiency, and one of the things that, just to frame the, your thinking process, you think about, demand response as more of a short-term, shaving down the peak, and think about energy efficiency as more of a longer-term, reducing the average consumption. And on that front, there's a lot of potential. In particular, in the state of Texas, high-efficiency heat pumps is something that we are looking to very seriously. So.
Yeah, absolutely. So energy efficiency can receive capacity value, capacity revenue in PJM. It's an important part of our portfolio. One of the things that we are grappling with, especially as technology evolves quicker and quicker, is how do you measure baseline, especially for impact, for the purposes of impact. When technology changes slowly, you can say that this specific intervention reduced energy consumption by X%. When technology changes very rapidly, what you use as the baseline of impact also can change very rapidly, and which baseline you use impact on the performance value and the capacity value. So it's definitely something that we are grappling with today at PJM, but the value is there, and we have a lot of energy efficiency participating in the market today as capacity.
And I guess maybe the only thing that comes to mind, and the clock is starting to count up, which is a bad sign for us. Yeah. And then maybe the one thing I think about with energy efficiency, it's a little distinct, is there's a lot of value in trying to reduce load overall. If I think back to the previous panel, though, and I potentially need that demand to participate on the essential grid services, that's an area where different types of controls and devices are going to be needed. With that, I'd like if you all help me thank the panel, and we'll. Great.